Assalamualaikum and hi, my name is Nurul Izzah binti Ahmad Naim. I am from class AS1201 underscore 6. My subject code is CHM131 and my lecturer's name is Madam Nurul Izzah binti Taib. So today I'm going to discuss about the gaseous state. So there are three subtopics under gaseous state that I'm going to discuss, which are properties of gases, pressure of a gas, and the gas laws. Firstly, we will talk about properties of gases. So, gases are one of the three major states of matter that we are all exposed to. So, the physical property of gases can be manipulated and measured more easily than solid or liquid state. This causes the mathematical relationship between different gas properties, were among the first quantitative aspects of chemistry to be studied. So from the table below, you can see the difference between solid, liquid, and gas. The difference in density and compressible. It's stated there that gas has low density and it is compressible, while solid and liquid has high density and isn't compressible. So to explain to you why gas has low density and is compressible. So, gas has low density because density of a typical solid and liquid is around 2 g per ml, while density of gas is around 2 g per L. This means that solid and liquid is roughly around 1000 times greater than gas. So compressible. Why is gas compressible while solid and liquid isn't? So, for example, when a glass of water is full, you can't add more water to it. But when a car's tire is full, you can still add more air into it, but until it bursts. This shows that the nature of gaseous state allows you to press a volume of gas into a smaller volume. Liquid and solid isn't like that. They are essentially incompressible. Now we will talk about pressure of a gas. Gas exert pressure on surface measured as the force exerted on given area of surface, which is P equal to F over E, pressure equal to force over area. Gas pressure is commonly measured using a barometer. From the figure 11.1.2a, you can see that barometer consists of a long narrow tube that was sealed at one end, filled with liquid mercury, and inverted into a pool of mercury. The gas in the atmosphere pushed down on the mercury in the pool and balanced the weight of the mercury column in the tube. The higher atmospheric pressure, the higher the column the higher the atmospheric pressure, the higher will be the column of the mercury in the tube. The height of the mercury column, when measured in millimeter, gives the atmospheric pressure in units of millimeter of mercury, mmHg. So, the torr is a unit of pressure. 1 torr is equal to 1 mmHg. Torr is an honor of the name of the inventor of the barometer, which is Evangelista Torricelli. The pressure of the gas sample in the laboratory is measured using manometer, which is shown in figure 11.1.2b. In this case, mercury is added to a U-shaped tube. One end of the tube is connected to the gas sample under study, the other is open to the atmosphere. If the pressure of the gas sample is equal to the atmospheric pressure, the height of the mercury is same on both sides of the tube. But from the figure 11.1.2b showed that the pressure of the gas is greater than atmospheric pressure by h mmHg. So you can see the height. Gas pressure is expressed in different units. The SI unit for pressure is Pascal PA, which is equal to the force in newtons exerted on 1 square meter. 1 NE equal to 1 N over M. 1 PA equal to 1 N over M square. 1 Pascal equal to 1 Newton over meter squared. So now we will talk about the gas laws. There are 3 gas laws that I will explain to you, which are Boyle's law, Charles' law, and Gay-Lussac's law. So Boyle's law, the relationship between volume and pressure of a sample of gas under constant temperature condition was first described in 1660 by the English scientist named Robert Boyle. Boyle found that the decrease in volume can be predicted by the amount of pressure increases. Boyle's law stated that there is an inverse relationship between pressure and volume while the temperature is held constant. So V equal to K over P. V stands for volume, K stands for constant, and P stands for pressure. So, for example, consider a string that is filled with a sample of gas and attached to a pressure cork and thermostat. Thermostat is used to keep the system at a constant temperature. When the plunger is depressed, decreasing the volume of gas sample, the pressure of the gas increases. When the pressure on the string is low, the gas sample has a large volume, and when the pressure on the string is high, the gas sample has a low volume. As predicted by the Boyle's law, PV equals the same value in both experiments. So, thus, therefore, for a quantity of gas under two sets of conditions at the same temperature, we use the formula P1 times V1 equal to P2 times V2. So, for example, inside a certain automobile engine, the volume of the cylinder is 475 ml, while the pressure is 1.05 atm. When the gas is compressed, the pressure increases to 5.65 atm at the same temperature. What is the volume of the compressed gas? So from the question, you can see that it gives you V1, which is 475 ml, and it gives you P1, which is 1.05, and P2 is 5.65. So it asks you for V2. So V2 is equal to V1 times P1 over P2. So 475 times with 1.05 over 5.65. So the answer will be V2 equal to 88.3 ml. So furthermore, Charles' law, the quantitative effect of temperature on the volume of sample gas on the volume of a sample of gas at constant pressure was first advanced by a French scientist named Charles in 1787. Charles showed that any gas expands by a definite fraction as the temperature rises. He found that the volume increases by a fraction 1 over 273 for each 1 Celsius rise in temperature. Charles law stated that the volume of gas is directly proportional to the Kelvin temperature while the pressure remains constant. So V equal to K over T. V stands for volume, K stands for constant, and T stands for temperature. So hot air balloons are particular application of Charles' laws. It must have something to do with the gas balance. When air is heated, it expands and becomes less dense than the surrounding cooler air and thus rises. By confining the trapped hot air, the balloon and attached gondola become lighter than air and lift into the sky. So, for the quantity of gas at the temperature at the same pressure, we use the formula V1 over T1 equal to V2 over T2. So, example. A sample of gas occupies 250 cm cube at 27 Celsius. What volume will it occupy at 35 Celsius if there is no change in pressure? So, from the question, it gives you V1, which is 250 cm cube, and it gives you T1, which is 37 Celsius, and it gives you T2, which is 35 Celsius. But we have to convert Celsius to Kelvin, which 27 Celsius plus 273, which is equal to 300 Kelvin. And 35 Celsius, we plus with 273, which is equal to 308 Kelvin. So V2. Now to get V2, V1 times T2 over T1. So 250 times with 308 over 300, which is equal to 257 cm cube. Lastly, Gay-Lussac's law. The relationship between temperature and pressure was proposed in 1802 by Joseph Louis Gay-Lussac. Gay-Lussac law said that the pressure is directly proportional to the Kelvin temperature at constant volume, which is P equal to KT. P is pressure, K is constant, and T is temperature. So, application of Gay-Lussac law. Deodorant and hairspray. Deodorant and hairspray are one of the Gay-Lussac's law application. Do not incinerate or store on your head. These are the practical warning hints that is stated on the tin of the deodorant and hairspray. When a confined quantity of gas is heated, the pressure increases. Eventually, the seal on the can break and explosion may occur. So, for a sample of gas under two sets of conditions at the same volume, we use the formula of P1 over T1 equal to P2 over T2. So, example. A quantity of gas in a steel container has a pressure of 760 mmHg at 25 Celsius. What is the pressure in the container if the temperature is increased to 50 Celsius? So, I give you here is P1, which is 760 mmHg. Temperature 1 is 25 Celsius and T2 is 50 Celsius. But as you may remember, we have to convert Celsius to Kelvin. So 25 Celsius we have to plus with 273, which is 298 Kelvin, and 50 Celsius plus with 273, which is 323 Kelvin. So now to get P2, P1 times with T2 over T1. So 760 times with 323 over 298. So P2 is equal to 824 mmHg. So that's all from me. Thank you.